Alright, this video is going to be a review of factoring. So there's a few different types. The first type of factoring is taking out the greatest common factor. And I'm starting with this type of factoring because whenever you're factoring any problem, that is the first thing that you always want to check for. So if I'm factoring 18x to the third plus 24x squared, the first thing I want to look for is to see what number is in common between 18 and 24, and I want the greatest number. So for instance, like 3 is in common, but it's not the biggest thing that's in common. So 6 would be the biggest number that's in common. And then between the x to the third and the x squared, you always take the smaller exponent. So x squared would be what's in common. And then for my leftovers, 18 divided by 6 is 3. X to the third divided by x squared is just x. 24 divided by 6 is 4. And x squared divided by x is 1. And I don't need to write multiply by 1 there. So that's how you take out the GCF. We also have trinomials, and the ones where the x squared is alone are the easy ones, and some people call it the diamond method. There's a few different ways, but basically when you're doing these, what you're looking for are two numbers that multiply to the term on the end and add to the term in the middle. So I'm looking for two numbers that multiply to negative 12 but add to 4, and that would be 6 and negative 2. And so my factor would be x plus 6, x minus 2. The ones that are a little bit more difficult are still trinomials, but where you have an a value where the coefficient in front of x squared is something other than 1, and it's not a GCF. Like this is 7 does not divide into all of those. It divides into 21 but not 52. So 7 is not a GCF you can take out. And this, I've heard students at the school say something about headphones and some teachers call it slide divide bottoms up, some teachers just call it slide divide, but in this case, instead of looking at just the number on the end, you actually multiply these two numbers together. So 7 times 21 is 147. So we are looking for two numbers that multiply to 147 and add to 52. And if you're looking at a problem that is difficult to find the numbers for, you can get yourself a list of numbers that would multiply to 147 by graphing 147 divided by x and then looking at the table. So on the table, I would just look for, because all these pairs would multiply to 147, so if I'm looking for the pair that would add to 52, then I just have to look at my x and my y pairs. So 3 and 49 would be the numbers that would do it, and so that gives me x plus 3, x plus 49, and so that's the slide part of slide divide bottoms up. And then the number that I slid over to multiply by the end number, I have to divide on each piece. And then I would look at that fraction and simplify it if I could. So this fraction does not simplify, and this fraction actually simplifies to a whole number. So that factor is now x plus 7. And then on this factor we do bottoms up, and so that would be 7x plus 3. There's one more type of factoring, and I don't know if you guys have learned it before, and it's called factoring by grouping. And this is the one that shows up in kind of weird problems in calculus sometimes. So when you factor by grouping, you might see 4 terms instead of 3. And what we do is, and they can be kind of rearranged. It's often best if they're in decreasing order like this, but sometimes you can kind of rearrange them and make them work. And what you do is you split it into 2 separate groups. That's what it means by factor by grouping. And so here I would look for the GCF between these two terms. So if I look at this one, I can see that I have an x squared in common, and then I would write what's left over. So there's an 8x minus 3 on this one. And then over here, anytime you have a negative in the front, you always take out a negative as the GCF. So I have a negative 2 in the front that I could take out, and that would leave me with positive 8x minus 3. And so now if I can look at it this way, if you can picture this, this is kind of like a GCF problem where I've got something multiplied by something else and something multiplied by something else, and 8x minus 3 is like my greatest common factor. So I would say that both terms, I've got one term right here and one term right here, and both of those terms have an 8x minus 3, and then if I write my leftovers would be x squared minus 2. And then from there, now we know in calculus that even if this isn't a perfect square, you can keep kind of factoring that. So I'm going to say this is x plus square root 2 and x minus square root 2, and it's just beneficial to do that because that has been happening in our problems sometimes. Okay, so those are the different types of factoring that you're going to see the most often. One more thing we need to make sure that we remember how to do is to solve by factoring. So if we're going to solve by factoring, you need to be able to recognize that it is a problem that you can solve by factoring anytime you see a term that says x squared. If you see an x squared term, it's definitely solved by factoring. Sometimes you might see something that has x to the third and it's still solved by factoring because you can factor out an x. But we need to start recognizing that when we have these higher exponents, that it really means to solve this, you're going to have to factor it or use the quadratic formula or something. So to solve by factoring, you do need the equation to equal 0. So I'm going to go ahead and add the 4x squared. And I'll add the 7. So that means that my right side is 0, and on the left side I've got positive x squared minus 6x plus 5. And anytime you are solving by factoring, these methods, all GCF not so much, but using this method right here, which sometimes people call the diamond method, or using the slide divide method, these two methods that are the most common only work if the number in front of x is positive. So if you just need to be careful that if you do have a negative in the very front of your equation, that you factor out a -1 before you get started. So this was good because my x squared ended up being positive. And then I'm looking for two numbers that multiply to 5 but add to -6, and that would be -5 and -1. So in my parentheses I have x minus 5, x minus 1 equals 0. And then if you guys recall the way that you solve this, the reason you might remember, oh, it's the opposite sign. But the reason it's the opposite sign is because you have one number multiplied by another number equaling 0. And the only way that can possibly happen is if at least one of those numbers is equivalent to 0. So what we do is we just assume that both of the numbers are equivalent to 0. And then we go ahead and solve for the variable. So for this one, add 5 to the other side, we get x equals 5. For this one, add 1 to the other side, get x equals 1. So if you have factors that look a little bit more complicated than that, for instance, I know that as I've been working on answer keys in class, I might have something where I've got root 3x plus root 2 in a side of a factor. If you're unsure of how to get the answer for that, you can just take root 3x plus root 2 and set it equal to 0 and solve it. And that works anytime you have something in factored form.